A very good afternoon to my dear students of MSc and Tech. Today we'll be studying the use of remote sensing and GIS for horticulture application. So in the current study, I have taken Project Chaman, that is coordinated program on horticulture assessment and management using geoinformatics. So nowadays, the remote sensing and GIS is a very important tool that the government of India has stated that in the field of forestry and agriculture, the use of remote sensing and GIS techniques should be utilized, and it was initiated in September 2014 under the Mission on Integrated Development Program of Horticulture. Co-partners were MNCF, ISRO, IASRI, IMD, SR, SDOH, and HRDF. So, what were the main focus and the objective of the project Chaman? The objective was area assessment and production forecasting using remote sensing technology. So, for any kind of planning, like we have got a big mass of population where food grains, sufficient food grains is the requirement of each and every human being. You cannot survive without food. You cannot survive without water. So there must be a technology and a technique through which you can assess the damage, or you can estimate the yield, or you can estimate the total acreage in real time, so that you can plan accordingly. And various kinds of storage system, our population is big, various kinds of production systems are there, their rate has to be fixed. So all such planning has to be done using some technique, and that technique that government of India today approves is remote sensing and GIS technology, where various kinds of fruit assessment like banana, mango, citrus, vegetables like potato, onion, tomato, spices, chili are very important in order to have a price control, in order to see the stock, in order to identify the stock. Cold storage, in order to have better network analysis for better transportation. So whatever things that comes to your mind, and the technique that will be providing you the solution is remote sensing and GIS. So using the geospatial technology for horticultural development and management, we'll be identifying new sites where we'll be asking the villagers or the farmers to show new horticultural plants, so that the socio-economic condition of the people who are staying there can increase. So we'll be doing various kind of site suitability analysis. We'll be having a post-harvest infrastructure, crop intensification, what should be the cropping pattern, what is the health condition of the soil, what are the soil fertility, which kind of soil is suitable for which kinds of plantation or cultivation. So all such data sets, because we have got a large geographical area, so that cannot be manually handled, and you need a technology and technique, because without that the assessment, perhaps it's next to impossible. So you need various database creation is required, and all such creation will be displayed in web form through WebGIS, and any person who is sitting from Tamil Nadu or from Kerala can assess the, if I'm a investor, if I'm an entrepreneur, if I'm doing a business, as well as the government can assess the, for example, if we have taken the condition of an apple, so we can see what is the condition of apple in the real time, what is the production, how is the status, what is the kind of acreage we are expecting. So all such studies can be done in real time using remote sensing and GIS technique, and detailed scientific field level studies can be done using this technology. So how is it useful? Because at last you want to see the total area of onion that is cultivated, total area of soybean that is cultivated, because each and every crop involves area. So, for accurate assessment of the area, whether that is for Kharif crop or Rabi crop or millets or pulses or vegetables, it's quite tough. But satellite data sets provide you the signature, the characteristics. The area assessment can be accurately mapped using various satellite images. So it's useful for state horticultural department for crop intensification, inputs for rejuvenation of orchards. If you want to go for new orchards, plantation, new horticulture plants to be grown, will be suggesting them according to the soil condition, environment, temperature, climate, precipitation. So all such studies can be done with the use of remote sensing and GIS technology. Horticultural map is useful for planning post-harvest infrastructure like cold storage, market. I've already stated, because whenever you're doing any kind of vegetable products, if you're involved, if it is not going directly to the cold market or it is not going to the users, it has got limited period of time where otherwise it will be fully rotten, it will be a waste. So you have to see the local market where it can be transported, what will be the transportation cost, what is the amount that is to be paid to the villagers, what the money that a user have to pay. So all this rate fixation of the products depends on the networking, and this networking is totally based on remote sensing and GIS, which can provide you the real information in real time. So geospatial database of horticultural crops like other like road, settlement, market location provide important inputs for horticultural development and management planning. So whenever you need to have a decision support system for any kinds of crop, whether that is rice or whether that is a wheel. So remote sensing satellite images, using that you can identify the nearest road, settlements, market locations. So all such things are possible using remote sensing and GIS. So you can see that how the remote sensing and GIS, the various districts of various blocks of various states were taken into as a pilot study. So you can see that how the satellite images, you'll be seeing the different kinds of vegetation or different kinds of crop cultivation, because each and every crop has got a different spectral response, different spectral characteristics, have got a different canopy cover, and on the basis of that each and every crop behave differently. So using the satellite images, using a standard false color composite, you can see that at least we can identify at least 3 to 4 types of cultivation from the current satellite images, where you can see there is a smooth type of a feature in the area. So this will be the same object, then you've got a similar pattern that you will be seeing along the vegetation in between, and there is a particular pattern that you're seeing. So that is a plantation that they have grown in, and in and along there are some vegetation. So this plantation you can see in a straight line with a rough texture, and the same area you will be seeing in the field. So such kinds of plantation, you can see the growth, you can see their health, then you can see their status, whether there is any disease infection or what is the growth. So all such kinds of phenological analysis or the multi-temporal supply satellite data provides you the real information about the growth, about the acreage, about the yield, about the plantation. So you can see that without going into the field, we can directly map the entire area of how much area has been planted, what is the condition, where there is any disease infection or not. So such kind of studies can be done using satellite images. So a large area can be seen, and you can see the various kinds of transport networks that are associated, and you can directly mark those important location marketplaces that are located to your near agricultural field, and you can directly send into the market. So in this right hand side you see as geodatabase GIS layers been created, and on the basis of this, we have created the various legends where the various kinds of cultivation like potato, mango, onion, and various other production has been taken as a pilot example, and will be identifying those inventories will be done. So what we are trying to do and what we are trying to do is horticulture crop inventory using remote sensing. So in the current study, we'll be taking example to how the remote sensing and GIS technology is used for mapping and monitoring of this horticulture crop inventory. So first, what we'll be doing, we'll be taking a georeference data set, and because this features or the vegetation that we are copying or we are mapping requires a high resolution satellite data sets. So the Indian satellite currently in a multi-spectral mode with a high resolution is least 4 data set or least 3 data set with a coarser resolution if you compare that with the least 4 data set. So in the current study, we have taken both the data sets related to least 3 and least 4, and the same features were identified in the satellite images and the corresponding field photographs were attached to it. So you can see that how the plantation, banana plantation looks like in the satellite images, the dark red color with a smooth texture because of the big plants, canopy cover. It provides you a smooth reflectance, and this is the field photograph of the adjoining or the place that we have identified or marked as a banana plantation. In the second image, we have marked the various mango trees that are associated in and around the area of interest, and the same field photographs is attached to strengthen our results as whatever we have mapped in the satellite image, how it looks like in the field. The third one is a sugar cane, how that has got a particular pattern and a shape and size and how it looks like in the field. Fourth one is fodder crops that are grown for animals. So you can see large bunk of fodder crops being grown, and how does it looks in the satellite images and how you will be seeing that in the field. And the last one is tobacco cultivation that the peoples are doing in various parts, and how the same feature will be verified into the field, because field photographs is very important whenever you are trying to map any object based classification, because until unless you are not validating it with the ground, the accuracy may differ. So so we can see that in a single satellite image how we'll be identifying the different kinds of horticultural plants on the basis of their spectral response curve or signature in the satellite images. So what we have taken the least 3 and least 4 data. We have georeferenced the data. After getting georeferencing, we have calculated the NDVI, normalized difference vegetation index, where it's the best technique where you can identify the various kinds of water body or forested area or healthy vegetation or various kinds of soil. So this NDVI provides the best estimation over the peak months, and then peak identification signature of the crops were performed. They were questionnaire, the field photographs were taken, the ground routing were performed to identify the various kinds of species, the density, and you can see that we have created a profile of various kinds of agriculture. You can see the various kinds of months are there, and along that we have got a NDVI reflectance. So you see that the various kinds of banana, sugarcane, tobacco, and wheat behave differently in different months. So we'll be identifying those spectral response curve for the status of their health, for the status of their growth, and finally we'll be classifying our satellite images using supervised image classification technique. As we have got two methods through which you have got soft and hard key, soft classification or hard classification, through which you can classify the satellite images. Hard classification means we are trying to classify it on the basis of tone, and the common techniques are unsupervised and supervised classification. Unsupervised, generally the computer classifies the image object on the basis of clusters, and on in contrary to supervised classification, we provide training set signatures to the images, and on the basis of those signatures and training sets, the entire satellite images is classified using hard classification. And using soft classification, we'll be conducting the artificial neural network is there, then you got object-based classification is there, artificial intelligence is there, then various other techniques are available where you will be classifying the satellite images. So in the current study, as we had the field photographs available with us with their corresponding signatures, we have recorded. So we will be classifying it using a known feature, that is the ground truth data, and will be performing the classified supervised image classification. And finally, all the image what we have classified will be taking out the accuracy assessment of each and every horticultural plant, because the image accuracy is important, because until unless your image is not accurate, the amount of classification or whatever area statistics or whatever planning that the administrator will be performing has to be near about 100% accurate. So for that, accuracy assessment is an important tool that has to be performed in each and every image based classification method. And finally, we'll be correlating our supervised classification technique with the NDVI to see the total amount of any particular kind of vegetation. If your vegetation is interested in banana, so we'll be taking out the total area volume of banana. If you're interested in tobacco, we'll be taking out tobacco. If you're interested in sugarcane, so we'll be taking out the total area of sugarcane. So district level inventories of mango, citrus, bananas can be object using object based classification. And you can see for few states, for the case study were taken from Gujarat, Madhya Pradesh, Bihar, and Uttar Pradesh. So few example ke how those satellite images are seen in least 3 and least 4 data, and what are the accuracy of the map classes using satellite images. So you can see that a few sample sites we have taken, ground truth data sets has been taken for banana in Gujarat state. We have taken Anand, Bharuch, and Vadodara. They are the case studies that we have taken for the banana cultivation, and we have classified using object based classification. And you can see that the final product, the total amount of banana area has been demarcated, and when we have validated those into the field, the amount of those features or those classification area that we have classified is near about 85 to 92% of accuracy. Then we'll be comparing that with a mango, and when you will be seeing the accuracy is on a poorer side, that is 60 to 75%, because many times it gets intermixed with the various plantation, because maybe adjacent to mango tree you have got a neem tree or some other plantation is in around. So many times you may get confused because its tonal signature is same to the other plantation that is grown near the villages. So but still you have got 60 to 70% accuracy in the classified image. And finally the citrus, and that is accuracy is near about 65 to 80%. So you can see that using this satellite-based observation, we can map the entire trend. What is the trend in the area? Whether there is a positive change or whether there is a negative change. So we have taken the NDVI trend. We have calculated the NDVI from the year 2000 to 2004, and then we have taken out the positive change, neutral change, and the negative changes. So you see that the positive changes are in previous year, this areas where the plantation were of various other types, but now the people have migrated and they are going for mango cultivation. But somewhere down the lines you can see that somewhere you're finding red color patch also. So that is because of the declining, maybe because of some diseases in the plant. So we have to go and we have to check why that things are being taking place at that particular point itself, because it is not throughout the area, it is specific to maybe they are cut down, or they maybe they are old. So we have to go and we have to see in the field what is the real situation, and then we'll be coming up with a management strategy. And the second example, you can see the declining of 2014 to 15. So you can see that previously a large area was grown under apple irrigation, but now the area is decreasing, and the red color is indicative of the negative changes. That in previous past these were all apple orchard, but now it has decreased. So we have to see that, because until unless you are not seeing, so if you don't have proper amount and proper quantity of apples, then you have to get those products exported from various parts of the world. So that has to be done prior to the season, otherwise the price of the product will be very high. So in order to maintain the pricing, its prediction prior to the deficiency in the markets has to be calculated from the government in India, so that at real time we can place a order to the adjoining countries, and we can have a fixed pricing that won't fluctuate, and that won't be a big burden to the common human being or the common citizens of India. So you can see that how the agricultural practices of orchards are declining to 28% in Simla, and Lucknow 3 to 32 3.22%. Apart from this, the GIS provides you the basic understanding of the terrain, like what is the road network, railway network, the settlement area, your major production house, your storage. So accordingly, the villagers and the persons who are involved in such kind of agricultural practices and their networking can plan accordingly. So using this satellite images with GIS, GPS, spatial data, non-spatial data, we can create the different district boundary. We can create the different village locations which are associated in those areas. Then which are the villages which are on the priority zone, which are the areas which are under the non-priority zone. Potential wetlands priority, which are the areas which are having the potential land priority. Then yeah, not potential zones, then Makhana ponds. So all such information, real time information can be calculated, and area estimation, and the total number of ponds or that has to be constructed in priority one and second, and the geogenesis can be calculated using remote sensing and GIS technique. So you can see that intensification, what is the seasonal fallow in Rabi season in 2015, then the summer fallow, then the Kharif fallow. So you will see that the maximum fallow land is in summer season, as because of the low amount of underground water table. So in the same way around, you can create the a classified image of 2015, then a classified image of summer fallow of 2015, and then of Kharif, and you can identify the different kinds of build up, water, taluk boundary, block boundary, or village boundary, and for each and every month, what was the amount of kharif vegetation that we have done in second month, what is the status in third month, what is the station in fourth month, what is the station. So using the satellite images, the multi-temporal statistics related to various agricultural practices, their network analysis can be performed using satellite images. So without going into the field, we can have a real understanding of the area, and we can map and we can plan accordingly. In the second hand side, we are providing some site suitability area where various kinds of multi-thematic analysis were performed, various kinds of weightage were assigned, and finally we have calculated what are the current amount of zoom cultivation, how much area more it is suitable, and what are the area under abundant, and what is how much suitable area is available. So all the various kinds of priority donations, the abandoned zoom, current zoom, road settlement, buffer analysis, proximity analysis will be performed to identify the various agricultural practices that we are performing, and we can say about the current condition of that area, and we can identify the suitable spots. So development of automated tree counting algorithm and software using Carto set 2 and least 4 data sets. So GIS not only helps you to map the total area, you can calculate the exact number of automated trees using various algorithms. So what we'll be doing in the current study, we'll be taking a lease for data, we'll be taking a cartoset data. Lease for data is a multispectral data and cartoset is panchromatic data, and on that we'll be doing a resolution merge exercise. Why? Because in this cartosat data, that is a black and white data, and least 4 is a multispectral data, but this cartosat 2 has got a high spatial resolution and least 4 has got a partial spatial resolution if you compare with cartosat 2. So we'll be taking the best product from both of them. So we'll be taking size from cartosat and color from least 4, and we'll be performing the pro transformation resolution, and finally we'll be having a multi-resolution mods. Thereafter we'll be performing the segmentation, we'll be performing the object-based classification, we'll be selecting the various parameters for the class assignment, and we'll be classifying the image. Post classification, that is a raster image, we want to get the area, so we'll be converting the raster data into the vector data, and finally we can calculate the exact amount of mango orchards in that area, and finally we'll be performing a ground truth verification in the area to detect the amount or the area what we have generated using the softwares, using the satellite images, whether they are true, or what is the amount of deviation that you can see or you'll be finding in the field. So not only that, we'll be determining the different kinds of analysis to identify the various kinds of crop, various types of trees. So you can see that we can easily identify each and every tree using the satellite remote sensing. So this is the classified orchards. Then this is a pan image of the same area. Then we have detected the various kinds of trees using the various algorithm, and this is a zoom image of those two areas where you can identify the each and every tree. We can count what is the total number of trees. So without going into the field, you can see that we have calculated, we have identified the various amounts of plots, their agricultural practices, the number of trees, fallow land, bare land. So all such practices are very easily possible using remote sensing and GIS technique. Nowadays, each and every portion, just like we are doing health insurance, or somebody is taking personal insurance, somebody is taking accidental insurance, somebody is taking car insurance. In the same way, the government of India has ensured the scheme of crop insurance, because many times the citizens were taking a lot of loan, and there was a lot of suicide coming up because of the natural damage or because of some calamity in any area. So in order to understand the real understanding of that area with the real scenario, whether their agriculture were affected by those natural disaster, or what is the truth. So best technique to identify or to perform a crop insurance is a space technology. So the background of evaluation of crop insurance of India, crop insurance scheme, CCIS Kharif 1985, Kharif 1999 scheme was demand driven, and moreover claims were based on occurrence of natural calamity like drought and floods. Thereafter, Natural Agriculture Insurance Scheme was initiated under Rashtriya Krishi Bima Yojana, where 25 states and 2 union territories for 33 years we have created the database. Thereafter, we have the government of India created a pilot modified natural agricultural insurance scheme in the for the year in the 11th year program for the Rabi season, where major improvements were made in MNEIS, where actual premiums with subsidy in premium region up to 75 to the farmers. So you can see the various pilot weather-based crop insurance, then pilot coconut palm insurance, national crop insurance program were funded, and gradually the government of India has intensified those programs. Now we are going for Pran Mantri Fasal Bima Yojana PMFBY, keeping in view of the representation from various states and utilities, especially on the account of increase in premium rates and farmer share in premium, capping on premium rates, reduction in some reduced They all have been recently reviewed, and a new scheme, Pradhan Mantri Fasal Bima Yojana, has been approved in place of MNAIS and AIS for implementation from Kharif 2016 season. Premium structure and the restructured WBCIS has also been rationalized and made at par with MFBY. So unified package insurance scheme is there covering other risk of farmers including life, accident cover, house, tractor, pump shed, student safety. Besides crop insurance has also been improved for implementation of pilot project in selected 45 districts. So, Pradhan Mantri Fasal Bima Yojana will provide a comprehensive insurance cover against failure of the crop, thus helping in stabilizing the income of farmers and encourage them for adoption of innovative practices. The scheme covers all foods and oilseed crops, annual commercial horticultural crop. The scheme is compulsory for loaning of farmers obtaining crop loan KCC account for notified crops. However, it is a voluntary for other non-lean farmers who have insurable interest to be insured crops. The scheme provision has been simplified for easy understanding, and the maximum premium payable by the farmers will be 2% for all Kharif food and oil seeds, 1.5% for Rabi and oil seeds crops, and 5% for oil and horticultural crops. The difference between premium and rate of insurance charges payable by farmers shall be shared equally by the center and the state. The scheme will be implemented by AIC and other empaneled private general insurance. Selection of implementing NGC will be done by concerned state government through bidding on premium rates. The existing state-level coordination committee on crop insurance subcommittee to LCCCI district level monitoring DLMC shall be responsible for proper management of the scheme. The scheme shall be implemented on area approach basis. The unit of insurance shall be village panchayat level of major crops, and for other crops it may be a unit of size about the level of village or village panchayat. The increase a majority of farmers in the notified area are prevented from sowing planting the insured crop due to adverse severe condition. Then insured crop will be eligible for indemnity claimed up to maximum 25% of the sum assured. Claims for widespread calamities are being calculated on area approaches. However, losses due to localized perils, hailstorm, landslides, and inundation and post-harvest losses due to specified poles, cyclone, cyclonic rain, and unseasonal rain shall be assessed at the affected insurance field of individual insured farmer. So you can see a lot of scheme coming and how remote sensing helps. It will be providing the crop area discriminancy, preventing sowing not sown area, loss of crop due to epidemic episode, remote sensing in indices based crop cutting, experiment sampling frame, woman linked mobile application for collecting CCE data and crop status information, crop yield estimation using RS based inputs and yield map at district, block, and village level. So you can see that remote sensing and GIS helps a lot of V's for the crop cutting estimation for crop insurance. So in the various screen, you can see that the a case study of assessment of crop damage due to hail using remote sensing and weather data was performed by Space Application Mahapolice Center, New Delhi State Remote Sensing, State Department of Agriculture. The objective was to find out remote sensing and weather data combined index to quantify the loss in wheat crop due to hail. Unseasonal heavy rainfall occurred in February 2015 to estimate the yield rate reduction in the study area using a model with the weather and space-based input. So, six districts were taken. They were Bihar, Haryana, MP, Punjab, Rajasthan, and UP. Validation in three districts were performed: Madhya Pradesh, two spots, Rajasthan, two spots, Uttar Pradesh, two spots. So you can see the identified area, and then we have computed the hailstorm damage severity index. So what does it do? It takes the rainfall data from IOD, temperature data from IOD, and multi-temporal MODIS data. And interpolation was made on 5 to 5 kilometer grid, and using the MODIS data, we have calculated the NDVI using NIR minus R by NIR plus R, And then using interpolation, we have classified that into four categories. With the area having more than 100 mm, we provided the weight 4, with 40 to 100 weight 3, 25 to 50 weight 2, and 0 to 25 weight 1. The same is for the temperature more than 8 degree, it was 4 rate, 6 to 8 degree 3 weight, 3 to 6 degree 2 rate, and 0 to 3 degree 1 rate. And in NDVI, if the NDVI value in percentage was more than 30, we gave the rate 4. If it was between 20 and 33, between 10 and 22, and less than 1, 3. And all these parameters were added in GIS data map to create a hailstorm damage severity index, where the weightage more than 9 was classified into extreme, 7 to 9 in severe, 4 to 6 in moderate, and 2 to 3 into mild category. So you can see that India level NDVI anomaly was prepared from 1 November to 17 February 2050, and all the area was reclassified. Density slicing was performed to see the status of vegetation, where the vegetation health is good, where moderate, where nil, where low. The same is we have taken the IMD data to see the weather extreme, in that when the rainfall was high, when low, and when there is no effect. So that was differentiated and classified using interpolation technique to classify in six zonation, and that is extreme, severe, moderate, mild, and no effects. And same is for the temperature. The entire India was classified in the various temperature categories, and on the basis of all this measure, the data that we were given from IND data were interpolated to create a rainfall map of that region. Using the density slicing, we provided the various colors to various maps, which indicates the various categories of the land. And on the basis of that, we can see whether the rainfall was good, bad, what was the intensity, what was the amount. And on the basis of that, we have calculated the area wise, what was the changes in the area, the production and the yield, how much area was grown, what was the production, and what was the yield in that area. So you can take out in the real time all the damage assessment, all the area calculation, the positive changes and the negative changes. So you can see that in Madhya Pradesh, the area production has increased a lot. So we'll be taking that as a role model, and we'll be stating the other states to follow the same thing. Then we have been going into the field, and then you have to see whatever things what you state, what is the field condition. So you can see the field were damaged, so you have to take the field photographs. The entire agricultural product were destroyed, so you have to help these farmers, otherwise they'll be in a big trouble. So the government of India, using remote sensing data, provides the crop insurance to each and every land, so that the villagers doesn't have the risk, and they can use this satellite remote sensing technique to model the what is the cropping pattern, what is the yield, using the various indices. So you can see that semi-physical process model that is being used. We use the different kinds of models that is used for calculation of the total amount of rainfall. The same it was carried for the Rabi season. You can see that Karnataka, there is Gulbarga district. So we taken all this thing. The objective was to develop standard operational RC-based CC frame. So we are going to evaluate this data sets. So we will be doing the CC sampling procedure based on remote sensing. This is the satellite image, and on the basis of that, we have classified the Rabi sorghum's classified image using the multi-temporal data sets. And after that, stratification based on RS data were performed, where various kinds of A type, B type, C type, and D type was evaluated, and finally we proposed the CC sites in different state. You can see the various point location. So using the satellite image, you can see that any person who is not having a basic background of geography, geology, agriculture, but after seeing the map, anybody can understand what we are trying to say, and what are the kind of implementation and the management strategies that the government of India is doing to improve their socioeconomic condition. Apart from this, remote sensing data also help you to identify the various kinds of cadastral mapping of each and parcel of land is doing, and then we'll be going and verifying that into the field. What is that spot? How it looks like? What is the harvesting? What is the weight? To calculate the exact amount of weight. So you can see all this exercise that has been successfully uploaded in the Bhuvan website, where you can go for the crop cutting season, their accuracy, their survey number, all the things are properly enlisted, and the field experiment being done to see the what is the real amount of yield or that is obtained from the ground grade measurement, and the same will be correlated with the satellite image, and you can see what is the amount of accuracy that we are stating, whether the satellite data do provide the real measurement or what is the deviation. So you will be taking the different weights. You see the field exercise that the various scientists are performing in the field, and the same will be correlated with the satellite data sets observation that we have performed in the field, and we'll be seeing the accuracy of the data sets, whether the accuracy of the data, whatever we are stating related to the biomass, related to the weight, we'll see the accuracy, and you can see that the accuracy of the data sets are very high if you compare that with the satellite based data sets and that with the field based data sets, and various kinds of statistical analysis will be performed using remote sensing data. You see, this is a satellite image. On the basis of that, we have performed the NDVI analysis, then LSDWI, and various indices have been performed to calculate the exact amount of yield estimation, or if we want to give the primary production of any area. So using that data sets, yeah, village wide yield can be calculated. So you can see at a village we can calculate what is the village boundary, what is the amount of acreage or yield that we are getting from each and every parcel of land, and that can be seen in the real base data sets. We correlate the secondary data with the primary data to get. So using this, we can see that which are the lands which are providing more than 1000 kg per hectare, then 3500 to 4000, then 3000 to 3500 kg per hectare. So we can have an accurate assessment prior or during the field, and we can plan accordingly. So that is of great help. And nowadays, what does satellite data do? We'll be recalling it. That provides crop area discrepancy, preventing sowing, not sowing area, loss of crop due to episodic event, remote sensing indices based crop cutting experiment, sampling frame, human link mobile application for collecting CEC data and crop status information, crop yield estimation using RS-based inputs and yield data and districts and bond legal. So you can see all these data sets, how we'll be doing the various kinds of sampling, we'll be going into the field, then how we will be overlaying those yield estimates with the field-based instrument, and finally we'll come up with the output where the RS-based indices CE sampling frame will be generated, technology-based CEC data will be collected, crop yield based map using remote sensing data will be performed, and finally we'll be doing all kinds of crop damage assessment in case of there is some drought or flood in an area. So nowadays, not only remote sensing data, the drone technology is equally important, and we are using this drone technology for the local level study, and we can use the drone technology, the remote sensing data, the field data, and using all this data, the prime responsibility of any technology or any technique is to help your farmers, because more than 70% of population in India are still dependent on agriculture. So, if any technology or if any subject can help those farmers to improve their crop production, or to help them in getting more money, or can provide them an alternative source of plantation, key according to your field, what should be the cropping pattern, which crop should be grown, what will the date, what are the different uh, precautions that has to be taken into the field, how you will be putting the various kinds of fertilizers over the field. and in case there is a disaster, we can provide the damage to that particular portion or that people directly to their account using the Aadhaar card that has been interlinked to the PAN card, and the entire database is in the form of cadastral, and there we have attached the name of the landholder. So, in case there is a flood, we'll be overlaying the flood layers with the agriculture area, and we can see ki what area that particular portion, like there is two brothers and both hold 10 acres and other hold to 5 acres, and out of that one has 1 acre damage, another has 3 acres damage. They have claimed 5 acres each, so we'll be saying the exact amount of damage was 1 acre and 3 acre, and per acre the government of India, for example, says 50,000 rupees is transport. So we'll be depositing 50,000 rupees to X portion, and it was 3. So we'll be multiplying 50,000 into 3, and 1,50,000 will be directly deposited into their bank account. So there will be no corruption, there is no in between any portion, and at last the prime focus or prime objective of any technology is to bring happiness in the society. So remote sensing and technology, if it's properly implemented in real time, properly awareness program is generated among the villagers. So in coming years, you will see a more good and accurate assessment being performed by the various states of India. With this, I'll be concluding my today's presentation. Hope you enjoyed. After this presentation, we'll have 10 minutes of group and discussion. Thereafter, 10 MCQs, LMS you have to do, and thereafter we'll end our class. Thanks for being patient.